Hello everyone. Today we are going to discuss about a topic programmable logic devices from the subject fundamentals of digital electronics. So if we see various programmable logic devices, mainly there are three types of programmable logic devices. One is programmable read-only memory, and second one is programmable array logic. Third one is programmable logic array. So if you see the difference between these three programmable logic devices, fundamentally they are consisting of AND array and OR array, but the difference is what is programmable and what is fixed. For example, if you see the programmable read-only memory, we have fixed AND array whereas a programmable OR array. So that is the nature of programmable read-only memory. And whereas when it comes to PAL, we have programmable AND array whereas a fixed OR array. And coming to PAL, it is a programmable AND array as well as a programmable OR array. So please observe the difference between these three structures. All comes under programmable logic devices only, but the way in which AND array and OR array is constructed, that is different. So PROM has fixed AND array whereas the programmable OR array, and PAL is having programmable AND array whereas a fixed OR array, and finally the PLA is having programmable AND array as well as OR array. So now we will see how to utilize these logic devices in the construction of Boolean functions. And coming to here, we are going to discuss about the PAL and PLA. Okay, so when it comes to PLA, programmable logic array, it is nothing but a prefabricated building block of many AND gate and OR gates. So sometimes that AND gate and OR gates may be replaced with NAND and NOR gates also. Why? Because we know that the NAND and NOR gates are universal gates. So they can be replaced with any basic gate. So here it is the any memory device or logic programmable logic device is nothing but a block of AND and OR arrays or AND and OR gates. Now if we see the PLA structure, so there will be some inputs, okay, and outputs will be there, but in between we have AND array as well as OR array. So the output of AND array will give us some product terms, whereas the product terms are given to input as input to OR array, and output of OR array will be treated as the output of logic PLA. So let us see here with an example. Here in this diagram we have a 3x2 PLA with 4 product terms. So means here 3x2 PLA means 3 inputs. Here in the diagram they are named as x1, x2, x3, 3 inputs, whereas the 2 outputs f1, f2. Okay, and there are 4 product terms. So of course this is all a Boolean function. So how we can implement a 3x2 PLA which is having 4 product terms with the help of PLA? Let us see. Okay, so here if we see an example, we are given with 4 different Boolean functions or expressions which are supposed to be implemented using PLA. So here the 4 Boolean functions are named as F0, F1, F2, F3. So each one is having some expression involving variables A, B, C, where each variable may be present in true form or complemented form. Now overall if we observe, there are different product terms. For example, product term AB is there. In the overall, in the 4 expressions of Boolean, we have different product terms. AB term is there, B bar C is there, and AC bar is there, B bar C bar is there, and term A is there. So these are the product terms present in the all the 4 Boolean functions. And how to get these Boolean functions is, for example, A, B. So when the inputs are A, B, so A will be 1, B will be 1, C will be not present. Similarly, B bar C is nothing but C, 0, and corresponding to C it is 1. Similarly, A C bar, corresponding to A it is 1, corresponding to C it is 0. Similarly, B bar C bar, corresponding to B it is 0, and corresponding to C it is 0. Finally, the term A alone will have 1 corresponding to the input A. Now coming to F0, F1, F2, F3 output terms. So if you see, F0 is having A, R with B dash, C dash. So we have in F0 column, we have corresponding to A, that is last product term 1, and also the second product term of F0 is B0, C0. So corresponding to fourth product term it is 1. So under F0 column we have 4 product term 4 and 5, 1 indicating that it is equivalent to A, R with B dash, C dash. Similarly, coming to F1, function F1, second function F1, we have 2 product terms A, C bar and A, B. So those are nothing but first product term as well as third product term. So we have 1 here corresponding to first product term and 1 corresponding to third product term. Similarly, for F2, 2 product terms B dash, C dash plus R with AB. So first product term and fourth product term. And similarly, last function B dash C R with A. So second product term and fifth product term. So here if you observe, A, B and A, they are reused. So we are making reuse of those terms. So this is called this particular matrix where first column product term, second column inputs and third column outputs is called a personality matrix of PLA. Okay, and here the notation what is used, input side is, if it is 1, the particular variable is present in that product term, and if it is 0, the particular variable is present in the negated form, and wherever there is a dash mark corresponding to any variable, it is nothing but that particular variable is not part of that particular product term. Whereas the output side, if we see, 1 indicates the term connected to output, whereas 0 means indicates the product term is not connected to the output. So that is the meaning of this table as well as inputs and outputs notation. Now coming to the implementation of the given Boolean function with the help of PLA. So we have 3 variables, inputs, variables A, B, C, as well as their complemented form, because few of the product terms are having complement form of the variable also. So A and A bar also we are taking as input with the help of NOT gate. Similarly, B and B bar, C and C bar, we are assuming these are available at the input side. So now our first product term is AB. So A and B are connected to one AND gate. Similarly, B dash C is the second product term. So complement of B and C is connected to second AND gate. And third AND gate is taking inputs as A and C bar. And fourth AND gate is receiving input as B dash and C dash. Whereas the last AND gate, which is indicating the fifth product term, is having input A only. Okay, now, so AB output of first AND gate, B dash C output of second AND gate, AC dash output of third AND gate, B dash C dash output of fourth AND gate, and A is last output from the fifth AND gate. So now coming to the outputs, we have 4 outputs: F0, F1, F2, F3. So F0 is nothing but A, R with B dash, C dash. So OR gate is used, which is connected to fifth product term and fourth product term, which gives the final output F0. Similarly, F1 is having two input or two product terms, AC dash and AB. So those are connected to OR gate, and output of OR gate is named as F1. And third, F2, B dash, C dash and AB are connected to third OR gate, and fourth OR gate F3, output of fourth OR gate is F3, whose inputs are second AND gate output as well as fifth AND gate output, nothing but B dash C or with A. So this is how overall the given Boolean functions F0, F1, F2, F3 implemented with the help of PLA. Okay, so this is how simply we can apply or we can use PLA to implement Boolean functions. Okay, now coming to the programmable array logic, second or we can say third type of programmable logic device is programmable array logic. Here also array of AND gates, array of OR gates will be there, but the difference is what is fixed and what is programmable. So here fixed OR array, whereas programmable AND array. So let us see. So this is an array logic, programmable array logic. Here when there are different outputs, so in this diagram we have shown 4 different outputs. So each output is connected to AND gates. So the AND gate output is connected as input of OR gate, and OR gate output is treated as the final output of a Boolean function. So this is how that means here programmable gates are AND gates, whereas OR gates are fixed. So here if you see, the OR gates at the output are having fixed inputs, and that means 4 inputs. This is one example, okay, where 4 product terms can be implemented. So let us see a specific example for this. So here we have W, 3 different outputs, W, X, Y, Z. So W, X, Y, and W is having A, B dash, C dash, R with CD. So 2 product terms, whereas X is having A dash, B, C dash, A dash, CD, R with AC, D dash, R with BCD, and whereas the Boolean function Y is having A dash, C dash, D, R with ACD, R with A dash, BD. So overall, out of 3 functions, first one is having 2 product terms, second one is having 4 product terms, whereas the third one is having 3 product terms. But here what happens is, in the implementation, even though first one is having 2 product terms, second one is having 4 product terms, third Y is having 3 product terms, we need to use a fixed number of product terms for each output. So that is because the function, Boolean function X is having highest number of product terms 4, we will use 4 product terms for W as well as Y also. So that's why in the implementation, if you see the first one W, actually there are only 2 product terms, but we are giving output of 4 AND gates as input to the OR gate. Why? Because here OR array is fixed. That means input to the OR array is fixed, whereas AND array is programmable. So that's why here, since only 2 product terms are there, one is A, B dash, C dash. So from the first AND gate, we are getting A, B dash, C dash. From the second AND gate, we are getting C, D. Whereas third, fourth terms are not required. So those 2 AND gates, even though we use them, we do not connect them to any input. So only the first AND gate and second AND gate outputs will be given to W, which gives us the term A, B dash, C dash, R with CD. Whereas coming to the second output X is having 4 product terms in the output. So here we need 4 product terms, 1 2 3 4. Okay, these 4, first one a dash b c dash, second one a dash cd, third one ac d dash, and fourth one is bcd. So since all the 4 terms are present in the second output, so output from 4 AND gates is given as input to OR gate, which gives the output X. And similarly, coming to the third output Y, here we have only 3 product terms. So, but even though the product terms are 3, we use 4 AND gates. Why? Because these AND gates are programmable, whereas OR gates are fixed. So, we use 3 product terms from 3 AND gates, whereas the 4th AND gate, since there is no 4th product term in the expression of Y, we use only 3 AND gates, whereas the 4th AND gate is not connected to any of the inputs. So that gives output Y as consisting of 3 product terms. So here we can say the disadvantage is, out of the 3 output variables w, x, y, x, y, even though one of them is having 2 product terms, one is having 3 product terms, and another one is having 4 product terms, we will consider highest number of product terms, and that is fixed. That means first one 4 AND gates, second one 4 AND gates, third one also 4 AND gates, but few of them are not programmed. By why? Because the product terms present in that particular boolean expression are less than 4, so they will not be connected to any of the input, and output will be simply the result of 2 product terms, or 3 product terms, or 4 product terms, depending on the number of product terms present in that particular expression. So here we can say this is one disadvantage. That means even though the number of gates are not required, we are forced to use the, of course that is how the structure is available. So the programmable array logic is having programmable AND gates and fixed OR gates. So programmable AND gates which requires 4 terms, so we fix 4, and the same number of AND gates are fixed to other terms also, which gives us overall the implementation of PAL. So this is the simple discussion on programmable logic devices, in which the programmable logic devices are 3 types: programmable read-only memory, as well as programmable array logic and programmable logic array. So here in this session we discussed about how to implement given boolean expressions with the help of PAL and PLA. So thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.